Hello and welcome back to Maths with Mitch. Today we are looking at linear equations, and I pose the question to you: can you sketch a graph in the form y equals mx plus c? If you can't, then keep watching this video and I'm going to show you how. So firstly, we're going to start with two equations. We're going to look at y equals x and y equals 2x plus 1. Now firstly you might think y equals x, that's not in that form that I just mentioned, but I can reassure you it is if you were to think y equals mx plus c. Here are m terms, so the coefficient of x is 0 and c, or constant term, is also 0. So y equals x is in the form of y equals mx plus c. So firstly we're going to look at plotting these graphs. So I can take the x term and we can look over a range of -3 through to +3, and we can then find the y term. So for here it's going to be nice and easy because y equals x, so our y term is the same as the x term. And for our second equation we have to do 2 times x, remembering that we got negatives here, and then add 1. So that's going to give us the following figures. There we go. Now we can use those. They are now giving us x and y coordinates, and we can plot them onto our graphs below. So let's start with y equals x. Just move down slightly. So we have -3, put it in the right place and that might help. We have -3, -3, -2, -2, -1, through the 0, 1, 2, 2, and 3, 3. And we know we're going to have a nice straight line because it's a linear equation, so we can then plot our line as so. That is our graph there, or close enough. And we can do the same for our second graph, so let's look at that. So -3 on the x, label these up, x, y, let's get that correct. -3 on the x, down to -5 on the y, and the same for the other points. And I'm going to go off the top so I can't reach that final one. So we will just draw the line. There we go, and that's close enough. So firstly, we can draw them, but what the exercise is asking us to do is to sketch it. So it's not asking us to plot the points, it's asking us to sketch it. So that means to know from looking at the equation some of the important points of the graph, and to be able to quickly sketch them onto the diagram and then label up those important points. So the first thing we can look at in terms of the characteristics of these graphs is how steep are they? So when we're talking about how steep they are, we're referring to the gradient of the line. So firstly, let's consider the gradient. So when we're talking about the gradient and the steepness of the line, we're effectively saying how far up has it gone in the y direction, or down, it could be a negative slope, across a period of 1 on the x. So we're effectively saying if we were to form a triangle here, for each movement of 1 in the x direction, how far up or down has it gone in the y direction? So we can think about it in terms of, if we were to just look at these points, we can pick, because it's a straight line, we can pick any point on the graph and we can use 2 points that we know. So here we can say this is x, and we can give it the subscript 2, so we're saying it's the second point on the x, and this is x1, and this we can say is y2, and this we can say is y1. Now here we can visually see that it's gone, for every 1 in the x direction that it's going to cross, it's gone up 1 in the y direction. But mathematically we could say that the gradient, which is going to equal m, is equal to the difference in y over the difference in x. So if we were to do it for this graph, our point on the y here is 2. So m equals 2 minus, then we look at our second point, the y is 1. Divide that by the same as for x, so x, 2 is 2, and x1 is 1. If we do the maths, then we get 2 minus 1 over 2 minus 1, so that's 1 over 1 equals 1. So our gradient is 1, and visually we just said that. For every 1 it goes across in the x direction, it goes up 1 on the y. So let's do that on our second one. Let's check to see if we get the result that we expect. So let's apply it here with a straight line. Use my ruler because obviously I'm terrible at doing this in freehand. Okay, now we are going to use, this line isn't quite on that point, but we are using the values at that point that we've calculated before when we plotted it. And we can say here, if we were to say the same thing, y2 minus y1 over x2 minus x1. So let's put in the points here. So this is y2, y1, x2, x1. So we can say on the y-axis here for y2 we have 3 minus 1 for this point, divided by, for this point here we have in the x direction is 1, and this one here in the x is 0. 3 minus 1 is 2, divided by 1 minus 0, which is 1, and that is 2. So m, which is the gradient, should equal 2. Now visually, does that look correct? So for every 1 we go across in the x direction, yeah, we can see that we've gone up 2 there in the y direction. Now also the interesting thing to then think is to look back at these original equations here. So we said here originally y equals x, and in the form mx plus c, we can say that that is the m value is 1, and we've proved that the gradient is 1. For this one here, we have y equals 2x plus 1, where we've proven that the m value here is 2, and that the gradient here is 2. Therefore, we can say that the m on these graphs is equal to the gradient of the lines. So next up in the equation, we've just said that's the gradient. So what does this c term mean? What is the constant term? Well, we can consider at the point x equals 0, if we were to make x equals 0 here, this equals 0, regardless of what the gradient is, m times 0 is 0, so that whole term becomes 0. So we are just left with an equation which is m equals y equals c at the point x equals 0. So the point x equals 0, what does that mean? It is the point at which the graph passes the y-axis. So as it crosses this axis, this line here, the whole of the y-axis is the point, is a line of x equals 0. So what we're saying here is the point at which it passes the y-axis, the value on the y-axis and the point at which it passes is going to be equal to c. So let's test that for these two that we've drawn. In the first one, y equals x, and there is no term after that, so the plus c is 0. C equals 0 for the first one. So does our rule apply there? So here is the point 0, 0. It crosses the axis. So when it crosses the y-axis, it is at the point 0. So what about for our second one? Here we have y equals 2x plus 1, so our c term is 1. So here, here is the point at which it crosses the y-axis, the point at which x equals 0, and we can see that here y equals 1. So we can see that the c value should be 1, and sure enough, when we look at the equation, the c value is indeed 1. So what we've said there, we've said the point at which x equals 0, the y term is given by the c value. So it's the constant term in the equation, and that's the point at which it crosses the y-axis, or crosses the line of x equals 0. So now we can use that knowledge to answer the question sketch, and then have an equation in the form y equals mx plus c. So as a reminder, y equals mx plus c, m is the gradient, and c is the constant at which it crosses the y-axis, or x equals 0, the line. Therefore, we can sketch it. So when we say sketch, we just want to draw a line and then to label up these key points. So firstly, if we take number 1 here, we'll do this in red. So we can consider, firstly, where is it going to cross the y-axis? The value is positive 1. So remember, you're using the sign as well. So positive 1. So we know it's going to cross the y-axis here at 1. And then we know this value is m. So the gradient is 3. So we can sketch a line and of course, because if we're sketching, we don't really need to label up anything on the x and y axis. We haven't plotted anything, so we can just label that line 3x plus 1, and you could say m equals 3 to say that that's what the gradient is. So let's draw this. Let's draw onto the same axes number 2. Let's do this in blue. So this time we have y equals 2x minus 1. So let's firstly think, where's it going to cross the y-axis? We have negative 1, so it's going to cross at minus 1. Remembering to look at whether it's positive or negative. And then we have 2x, so the gradient is going to be 2. So again, we don't need to plot it, but we need to be cognizant that when we sketch it, it needs to visually be representative. So if it's 2x minus 1, that means the gradient's less steep than the previous line, so it's going to be it's not going to be as steep. Now, I don't know exactly where they're going to cross, but we need to just show that that is a less steep line than the previous one that we've drawn, and then we can label that up. Y equals 2x minus 1, and say that the gradient is 2. And there we've answered the question of how to sketch a linear equation in the form y equals mx plus c. So thank you very much for watching. This has been Maths with Mitch. Please subscribe to the channel. Leave a comment if there's something you liked, didn't like, you want to see, or you want me to do, and I'll happily oblige. Thank you very much.